In this video, we'll continue our discussion of the chain rule. I gave the formula at the top, so we're just going to run through another example. So we have W that's expressed in terms of X and Y. Then we have X and Y, which is in terms of T. They want us to find dW dt. So I need to find each part that is in my formula there. So the change in W with respect to X. So I'm looking at W here. I got 3x squared Y plus y squared. X is the y squared is the constant in that case, so we have that. I'm going to go ahead and find dx dt while I'm here. That is going to be negative 3 sine t dw dy. Right? We have x cubed times y. That's going to be just x cubed, and then plus 2xy. And then we need dy dt, normal derivative, and that's just going to be negative e to the negative t. All right? To find my dw dt, I follow my formula. All right, I got 3x squared y plus y squared times negative 3 sine t plus x cubed plus 2xy times negative e to the negative t. Now, normally we would go back and we'd plug in, like, everywhere there's an x, I'd put that 3 cosine t, and everywhere there's a y, I would put e to the negative t, but we're really just finding dw dt when t is equal to, they told us 0. So I'm just going to figure out what is x of 0 and what's y of 0, and then just plug those in instead of going through and plugging the whole function. So 3 times cosine of 0 is 3. So all x's are going to be 3. And then the y is going to be e to the negative 0. Okay, well, that's just 1. So all the y's are going to be 1. And then t's are going to be 0. So I got 3 times 3 squared times 1 plus 1 squared times negative 3 sine 0 plus 3 to the third plus 2 times 3 times 1, and then negative e to the negative 0. All right, so we have this thing is equal to, okay, let's do this one. 3 squared is 9 times 3 is 27 plus 1 is 28 times sine of, oh, that's all 0 anyway. Sine of 0 is 0. So that whole first term goes to 0. Right, and then we get this term, this is a 1, so we're negative 1. So we're going to get negative 3 cubed is 27 plus 6. So we get negative 33. So that is the derivative of w with respect to y. Right, so in that direction it is going downhill. Right, so there is the chain rule. Again, another example. When you're plugging something in, you can skip the step that you're replacing all your x's and y's with their expressions and just go up here and plug them in to whatever value that you're trying to plug it in. Now, the downfall is like the problem in the last video where they didn't give us something to plug in. We would have to plug in all the x's and all the y's, and in this case, it would have been a little hectic, but it's still doable.